So we'll take a look at 40, part D. Number 40 deals with integrals, definite integrals involving the absolute value of a function. This is the integral from 0 to 4 of the absolute value of x squared minus 2x minus 3. It's real important. You just can't get rid of these absolute value bars and just straightforward integrate from 0 to 4. So the idea is, if we look at the function inside the absolute value, let's just take a look at that function, the function f of x equals x squared minus 2x minus 3. Well, that's a parabola opening upward. And I can graph that function. A good way I can think about what I need to know, though, is I can, in this case, factor this, right? This factors as x minus 3 times x plus 1, right? The inner and outer give me the negative 2x here. And because this factors, I can see clearly that this function is 0 when x is negative 1 or 3. And that's really enough for what I need to know. Let's put a, let's actually sort of sketch the graph of this function. We know at negative 1, and let's say 1, 2, 3, that the function is 0. Okay. Further, I know this is a parabola opening upward. You should all identify that, since the coefficient of the x squared term is positive. And so, you know, it's going to look something like this. And I can sketch it a little bit better, but this is sufficient for what I need here. So here is the graph of this function. Is this the function we're integrating from 0 to 4 in this problem? No, we're the absolute value of this function. So this is the graph of the function f. Now we are integrating from 0 to 4, okay? So as far as when we look at this, from 3 to 4, if we're integrating from 3 to 4, then the absolute value of x squared minus 2x minus 3 is equal to x squared minus 2x minus 3, because the output to the function is positive, right? The output is positive, and you take the absolute value of a positive number, then you get the same thing. However, when we look at between 0 and 3, what's going to happen? The output to this quadratic function is going to be a negative value. When I take the absolute value, that makes it positive. So what is the absolute value of the function f going to look like? Well, this whole negative portion here, when I take the absolute value, there'll be a reflection about the x-axis. So here is the graph in red of the absolute value of f. So it coincides with the graph of f when the function is positive, but when the function is negative, it does a reflection. And so the red is the graph of the absolute value of f. So now we see what we need to do. In order to evaluate this integral, we've got to break it up in two parts, right? From 0 to 4. Well, from 0 to 3, what are we integrating? We're not integrating the function, right, f. We're integrating the absolute value of x. So what's the relationship, right? This is also then what? Negative f on this segment right here. Right? Well, all the way from negative 1 actually to 3, but since we're starting at 0. So this integral is equal to the integral from 0 to 3 of negative 1 times this x squared minus 2x minus 3. Right? From 0 to 3, we have to multiply the function inside by negative 1, because we're taking the absolute value. That's how you, all right, so that's the definition, remember, of absolute value. So in other words, if I have the absolute value of f, then that's going to just be equal to f if so this is f of x, I say, f of x, if x is greater than or equal to 0, and negative f of x if x is less than 0. That's the idea that we're using here. But from 3 to 4, it's just the same function. So from 3 to 4, I literally can just get rid of the absolute value bars, and I just integrate, 2x minus 3, the actual function here. Right? So this is real important, that you are able to rewrite the integral involving an absolute value as the sum of two or more integrals, and that sum will depend upon how many times the function passes from negative to positive or positive to negative on that interval that you're integrating. Now it's just straightforward. We'll finish this out real quickly. I find the values of these definite integrals here. I would probably want to go ahead and distribute that negative sign through, which I'll do. change all the signs. And now what's the antiderivative here? This will be negative x cubed over 3. Antiderivative of 2x is x squared. Antiderivative of 3 is 3x. And we're evaluating that at 3 and at 0. And then here, similar, of course it's positive x cubed divided by 3. Negative x squared minus 3x is the antiderivative. And the rest is just, plug and chug, so to speak. Plug in 3 here. 3 cubed is 27 divided by 3 is negative 9, right? Negative 9. 3 squared, positive 9. 3 times 3, positive 9. Right? Minus what? Plug in 0 there, I get 0. Right? Over here, let's do this one, and then we'll come back to this one. If I plug in 4, 4 cubed is 64 thirds. Minus what? 16. 3 times 4 is 12. That's evaluating that at 4. Minus the evaluation at 3. Very similar to what we did over here. 3 cubed is 27, divided by 3 is 9, minus 3 squared, minus 3 times 3. Okay, so here I get a total of 9, right, when I combine. So this whole part is just 9. And it's real important, this 9 is important, because essentially that's the area under the graph from 0 to 3, right, and it's this area that we're finding here, right, because it's the absolute value we're integrating. And the other integral then will give us this area over here. And both of those should be positive. Both of those should be positive. Over here we get what? Let's see, I get 6, let me leave that 64 thirds there for a second. I get minus 16 minus 12, that's negative 28. Minus what? 9. Minus 9 is 0 minus 9, that's negative 9. Minus negative 9 is plus 9. And finally I can finish this off. 9 plus 9 is 18. 18 and negative 28 is negative 10. So I get 64 thirds minus 10, which is 64 thirds minus 30 thirds. 64 minus 30 is 34 thirds. And there's your answer, right? But again, the point is to understand how we take this integral involving an absolute value and break it up into 2 or more integrals without absolute values.